Well, howdy y'all. Welcome back to Multar Aviation. This is the 5th video series talking about aviation weather. In this video series, I'm going to be talking about atmospheric pressure and altimetry. So I'm Dr. Andy Multar. I'm a CFI II MEI. I'm a former corporate pilot, and I'm a professor of aviation. One of the classes I used to teach was aviation weather. And so you're getting a college education for free here on YouTube. So make sure to like, subscribe, and share. Stay subscribed so that way you can get notified every time I make a new video about the subject. And if you haven't watched any of my previous videos on aviation weather, please go back and watch those because you these are all basic topics that we've been talking about so far, but these are all important things that you need to know as things start to get more complex. And so in this video, we are talking about pressure and altimetry, including, and we'll even be talking about density pressure in this video series. So make sure you subscribe so that way you get notified when we come out with that video. All right, so over this set of videos, we're going to be talking about atmospheric pressure, pressure units of measurement. We're going to discuss how temperature, density, water, and pressure affect each other. We're going to be talking about the constant pressure charts and symbology. We'll be talking about the different types of altitude, and especially density altitude. I know how confusing that is for so many people. I'm going to explain that very clearly so that you understand it very well. All right, so atmospheric pressure, it's when we have atoms and molecules that strike a surface, they exert a pressure. And it's always occurring. You don't notice it because you're used to it. And all the air molecules combined exert a considerable amount of pressure. And so atmospheric pressure is described as the force per unit area exerted by the weight of the atmosphere. And so you got to imagine, there's a whole bunch of air in the atmosphere. It's very light, but because air is made up of, elements that have mass and we have gravity, that air has weight. And so in this picture here, we see a jar full of air and an evacuated jar, a vacuum. So it has no air in it, because it does have air, it's going to weigh more. And so in the atmosphere, you have all this air, and at the top of the atmosphere, there's very little air, so it has very little weight. But as we get closer and closer to the surface, it's all that air sitting on top of other air, and so all that air is pressing down onto the surface, onto us, and we call that pressure. And so to measure pressure, we use a barometer. Now, this Italian Evangelista Torricelli proved he could weigh the atmosphere by balancing it against a column of mercury. Torricelli was designed the first barometer, and we call it the aneroid barometer, which is the most commonly used by meteorologists and the aviation community. So an aneroid barometer, it uses a flexible metal cell, the aneroid, and it has a partial vacuum and a registering mechanism. And so here in this picture, we have this aneroid cell. And so as the pressure increases, I'll go ahead and turn on my laser pointer for you. And so as the pressure increases here, the air is going to compress this aneroid cell. But then as the pressure decreases, then this cell is going to expand. And as it compresses and expands, it moves this needle to indicate what the pressure is. And so now the question is, what units of measurement are we using to represent the pressure? So meteorologists worldwide measure atmospheric pressure in millibars. And so it denotes the pressure as a force per square centimeter. And then in 1960, the International System of Units was introduced, and so hectopascal was adopted in place of millibars. So I don't know, maybe some non-English speakers didn't like the way millibars was pronounced, so they came up with hectopascal. But these are equivalent; they're the same units, just different names. So many still use the term millibars, including us pilots. They're using METARs and species. And then in the United States, for our altimeters, we use inches of mercury. And so these are the different units of measurement depending on the context in which they're used. So when we're looking at METARs and species and U.S. weather charts, we're using millibars. Now here it says hectopascals, but just ignore that and we use millibars. And so standard pressure at sea level, and so anytime we're talking, if you remember back, we were talking about the international standard atmosphere. So the international standard atmosphere for pressure at sea level is 1013.2 millibars. And then in US aviation, for our altimeters, we use inches of mercury, which is 29.902 inches of mercury, standard sea level pressure. And then for US engineering, we use PSI, pounds per square inch, which is 14.7 PSI. Now you may be wondering, why do we use inches of, why was mercury, why did Torricelli use mercury instead of something else? Well, it's because mercury is the most dense liquid at standard temperature. And so when you look at the periodic table, mercury is a metal, and the next metal in the periodic table is a solid. And so mercury, because it's so dense, it was easier to measure pressure. And so here on this picture, we have two evacuated tubes. And to measure the pressure of air, you take this evacuated tube. So the tube is a vacuum. There's no air in it. And it's placed inside this mercury, this cylinder full of mercury. And the pressure of the air on a standard day would cause that mercury to rise 29.92 inches, which is about 2.5 feet. And if we did that with water, well, we would need we would need a tube that is so long that on a standard day that the water would rise 33.9 feet. And so it's just, not manageable to actually measure. So that's why we use mercury for measuring air pressure. All right, well, that's it for this video. Make sure you subscribe so you stay tuned for the next video where we're going to continue talking about atmospheric pressure and altimetry. All right, thanks for watching. You take care. Bye.